Welcome everyone. Today we are going to solve a problem from fortnight 31. This is a basic question asked in level 1 and this is targeting the grades 3 and 4 for lower level kids in our batch. Yet it is very interesting geometry problem. This is a kind of starting step towards Olympiad preparation. But our paper also contains game theory, paper folding and mathematical game related problems. We also have puzzles like Ken puzzles. You may have a look at it. Let's get started. Here is the question with 3 circles and you have the centers aligned or collinear lying on the same line. The first observation is that the radius of the first and second circles are equal. Because when you join one circle to the other, this acts as radius of both of them as it connects the center of the circle A to the circumference of the circle A, and also it connects the center of circle C to the circumference of circle C. So therefore the radius of both A and C circles are equal. So is the radii of circles C and B. Therefore all 3 circles have equal radii. Okay, after observing this, let's go back to the question. These 3 circles form a shape. We have to determine the perimeter of this shape. Perimeter is the outer length, like this length. And we must find this in terms of R. So curious students, please take a try at it before looking into the solution. We will get started now. So in order to find that, I can simply add the perimeter or the circumference, the entire circumference of the 3 circles to get 2 pi r times 3 and subtract the perimeter or the circle which are inside one another. So like this. I'll just remove these parts so that I get the required perimeter. So let's say this is 2 pi r times 3 minus inner perimeter. The inner perimeter just means these parts. But notice, finding them is not at all a difficult task. You have to first find the length of one of them. So there are 4 pieces. Let's find the length of one piece. That is this one, the highlighted one. Observe that the triangle formed by these 3 intersections will have all 3 sides as the radii. And all 3 are equal. Therefore, it's an equilateral triangle, which means this angle would be 60 degrees. As we know, all angles of equilateral triangle are 60. Similarly, the bottom triangle will also be 60 degrees. We thus notice that this piece subtends 60 plus 60, 120 degrees at the center of circle C. So the length of that piece would just be calculated by theta by 360 times 2 pi r formula, which is 120 by 360 times 2 pi r. 120 by 360 is 1 by 3, so I get 2 pi r upon 3. Now there are 4 such pieces, so the total length or the inner perimeter would be 2 pi r by 3 times 4. Now this is the exact value that I must subtract from 2 pi r times 3. So let's do that. This gives us 2 pi r times 3 minus 4 by 3 by taking 2 pi r common, which will give you 2 pi r times 5 by 3. And that is 10 pi r by 3, which will estimate the perimeter of this shape, and that is this portion. So we ask students to calculate such interesting ideas or lengths to come up with their own way, and we in fact give 14 days of time to think about these. If you want to join or solve these kind of problems, you may apply for a trial worksheet through www.sumonmath.com, and we will be really happy to serve you. Thank you everyone. See you in the next video. Bye.